Hello and welcome to MyScience Tutorials. In today's video, we want to look at the discriminant and nature of quadratic equations. Before we begin, if you are new to the channel, kindly make sure you subscribe to the channel and turn on that notification bell so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. Without further ado, let's begin. So, assuming we have a quadratic equation of the form as squared plus bs plus c, and we are asked is equal to 0, and we are asked to find the roots of this equation, we normally use the general quadratic equation, which is of the form minus b plus or minus the root of what b squared minus 4ac all on 2a. So it means our x value, if we solve this, if we do the substitution and then we solve the equation, we are going to get two values for x, and this is the formula that we use to solve quadratic equations. Now, if we look at the function under the root sign over here, that is b squared minus 4ac, if we take just this part of the equation out, that is, we have b squared minus 4ac, okay, this now becomes what we call the discriminant. And this discriminant is what determines the nature of the root or the nature of the quadratic equation that we have. So for instance, case number 1, if we have the b squared minus 4ac, okay, to be greater or equal to 0, then we say the equation will have what? Two real roots. Then the equation will have two real roots. 2. If the b squared minus 4ac is equal to 0 exactly, then we say the equation will have what? Two real and equal roots. Two real and equal roots. Okay, two real in the sense that we are going to get two real numbers if we are to solve this quadratic equation, and then equal roots as in the sense that because the two values are all 0, it means they are equal values of what real numbers, which is 0 and 0. So two real and equal roots. Now 3, if we have the b squared minus 4ac to be greater than 0, then we say we have what? The equation has two real and different or distinct roots. Different or distinct roots. Two real as in we have two real numbers, and then distinct or different roots because the value of s can both be either positive or both negative. Okay, so if they are both positive, they can be 1 1, they may be maybe 1 or 2, 1 or 3. So even though they are real numbers, they are different or they are distinct. So the fourth case we want to look at is when we have the b squared minus 4ac, okay, being less than 0. Okay, in this case, then we say the equation has no real roots, or it has a complex root. Now if you are given a question and then you are given one of these conditions, maybe two real roots, what it means is that you need to quote the discriminant and then you bring greater or equal to 0 to the equation and then you solve it. If the question says you have two real and equal roots, the key word here is equal root because real root is common to all of them. So if the question is saying equal roots, then it means that equate your discriminant to 0. If the question says they have two different or distinct roots, then it means what? Your b squared minus 4ac should be greater than 0 before you solve the equation. And then the same way, if the question says the equation has a complex root. What it means is that make the b squared minus 4ac to be less than 0, and then you solve for your values. Right, let's have a look at an application. So we have these two questions. We have 4s squared minus 12x plus 9 is equal to 0, and then we have s squared plus 5x minus 1 is equal to 0. And then the question says we are to describe the nature of the roots. So what it means is that we don't know whether this quadratic equation will have a complex root, or it will have equal roots, or it will have different or distinct roots. We don't know, and we have been asked to find the nature of the roots. So we know to find the nature of the roots, we use the equation b squared minus what, 4ac. So whatever the value or the answer we will get after we've done the substitution over here, that will inform us about the nature of the roots that we have been asked to find. So if I compare this first equation, let me use another color. If I compare this equation to the general way of writing a quadratic equation, that is as squared plus bs plus c is equal to 0, I realize that my a value, if I compare over here, my a value will be 4, then my b value here will be what, negative 12, then my c value will be what, the positive 9 that I have over here. So if I do the substitution, I'm going to have b squared minus 4ac, and that will be equal to, my b is negative 12, so I have negative 12 squared minus 4 into bracket, my a is 4, and then my c is 9. Now if I compute this into the calculator, I'm going to get a value of 0. So this implies that what, my b squared minus 4ac is equal to 0. And remember, we said that when the discriminant is equal to 0, it means it has what? It has equal roots. It has equal roots. So the nature of the root of this quadratic equation is that it has two real and equal roots. Let's solve for the II. So if I compare again, okay, this equation to the general quadratic equation, that is as squared plus bx plus c is equal to 0. My a value is the coefficient of the s squared term over here is 1. My b, okay, is positive 5 over here, and then my c is the negative 1 that I have over here. So to describe the nature of the root, I know that my b squared minus 4ac should be quoted. My b is 5, so I have 5 squared minus 4 into bracket. My a is 1 multiplied by my c is negative 1. So I have 25 minus 4 into bracket. Positive 1 multiplied by negative 1 will give me negative 1. And then it means I have 25. Negative 4 multiplied by negative 1 will give me positive 4. So I have 4 over here. So this is equal to 29. And 29 we know is greater than 0. So what it means is that my discriminant, which is what, b squared minus 4ac, is greater than 0. And remember, when we have the discriminant being greater than 0, it means it has what? It has distinct or different roots. So it means the nature of the quadratic equation over here, the nature of the root is what? It has what? Distinct or different roots. Different roots. Remember, it's always so it has two real, so it is two real, and before you add the equal roots, and then over here it is what? Two real, and before you add the distinct or different roots. Okay, so that is how you describe, or you are able to find the nature of the root of a quadratic equation. Now let's look at the application of this concept if we are being given the nature of the root, we are being asked to find a certain value. Alright, so I am to find the value of m for which the quadratic equation s squared minus 2mx plus into bracket m plus 2 is equal to 0 has equal roots. Now let's write down our solution. Before we start solving, let's analyze the question that we have. So we have been told to find the value of m for which the quadratic equation this has equal roots. The key word over here is what? Equal roots. Now remember, if we say equal roots, it means that the discriminant should be equated to 0. So what that means is that we have what? Our b squared minus 4ac, which is our discriminant, should be equated to 0, and that is the condition for us to have what? Equal roots. Now that we've found or we've stated the condition, let's now compare this equation to the general quadratic wave equation. That is, we have as squared plus what? bs plus c. If I compare this equation to this equation over here, it means that my a term is the coefficient of the s squared term over here, which is 1. Then my b term over here is the coefficient of the x term over here, which is negative 2m. So my b is what? Negative 2m. And then my c term is the coefficient or the constant over here, which is what? M plus 2. So all I need to do is to do the substitution of these individual variables into this equation at the top over here. So what that means is that my b squared will become what? Negative 2m squared minus 4 into bracket. My a term is 1 multiplied by my c term is what? M plus 2. This should be equal to 0 because that is the condition for us to have what? Equal roots. So this implies that if I square negative 2m, I'm going to get what? 4m squared. Then minus 4 into bracket. 1 multiplied by m plus 2 will give me what? M plus 2. So this is equal to 0. So all I need to do is to further break down this equation and solve for the value of m. So let's continue. So it means I have my 4m squared over here minus 4 multiplied by m will give me 4m. Negative 4 multiplied by positive 2 over here will give me what? Negative 8. And this should be equal to 0. We can see that we can divide both terms or all the terms over here by 4 and it will still be the same. So if we do that, we divide by 4 and by 4, we are going to get our equation to be what? M squared minus m minus 2 is equal to 0. Now that we have the equation in this format, all we have to do is to solve for the value of m. Now to solve for the value of m, we use the coefficient of the m squared term over here to multiply the c term or the constant over here. So it becomes what? 1 multiplied by negative 2, and that is what? Negative 2. So what it means is that, take note, this is not part, you need to do this in your mind. What it means is that we need to look for two variables or two numbers that if we add or subtract them, we get what? The middle value over here, which is what? Negative 1. Now if you look at it, if we have negative 2 and then positive 1, if we add negative 2 and positive 1, we are going to get what? Negative 1, which is the value of the m, the coefficient of the m over here. So it means these two values will help us get this negative 1 that we have over here. So what that simply means is that we have m squared, then you have minus 2m, then plus m, okay, and that will give us the middle negative m over here, then minus 2 is equal to 0. If you look at the equation, we've not done anything to this equation, it is still the same because negative 2m plus m will give me what? Negative m. So now that I have the equation this way, I can what? Factor out the like terms, okay? So I can see that m is common between, first of all, let me group like term because I have 2 here and 2 here, so let me group like term. So I have m squared plus m, then minus 2m minus 2 is equal to 0. So I can factor out m in this case. So if I do that, I have my m outside the bracket, then I have m plus 1 Okay, that means if I multiply the m by the m here, I get m squared. M multiplied by positive 1 over here, I get the m over here. Then minus, between these two, the negative 2 is common, so I factor the negative 2 out. Then I have into bracket m, then plus 1 is equal to 0. If I look at it, the negative 2 multiplied by m will give me negative 2m, as I have over here. Then negative 2 multiplied by positive 1 will give me negative 2. So it means I have not done anything different to the equation, and the equation is still the same. So it means my m will now be m minus 2, which is, I group these two guys, the coefficients that are outside the bracket outside. Then I have one of these, m plus 1, and that is equal to 0. So if I equate all of this to 0, I have my m will be equal to what? Positive 2, and then my m will be equal to what? Negative 1. That is, if I equate this guy, m minus 2 to 0, and then m plus 1 to 0. So what that means is that my m has a value of what? 2, or m is equal to what? Negative 1. And that is the value of our m for this equation if the equation has what? Equal roots. Let's have a look at another beautiful example. So the second example we want to look at is, we have to find the value of p for which the quadratic equation 2s squared minus ps plus 8 is equal to 0 has equal roots. Now, like I explained in the previous example, if you have an equal root, it means that our discriminant should be equated to 0. So it means that for our solution, we are going to write our discriminant, which we are now aware that it is what? B squared minus 4ac. We are now going to equate it to 0 to satisfy the condition that what? The quadratic equation over here has what? Equal roots. Now that I have that, let me compare these to the general quadratic equation format and have the values of my a, b, and c. So if I compare this to as squared plus bs plus c, it means my a value will be the positive 2 over here, which is the coefficient of the s squared term. Then my b becomes negative b over here, and then my c will be the constant, which is 8 over here. So if I do the substitution into this equation, I'm going to have my b squared. My b is what? Negative b. So I have negative b squared minus 4 into bracket. My a is 2, and then my c is 8. Then I equate this to 0. So it means negative b squared will give me what? B squared. Then minus 4 into bracket. 2 multiplied by 8 will give me what? 16, and this is equal to 0. So it means I have my b squared minus 4 multiplied by 16 will give me 64. This is equal to 0. So it means my b squared is equal to what? 64 over here, and then my p will be what? The root of what? 64. Okay, what that means is that my p is equal to, because we've taken the root sign of the value 64 over here, we need to add plus or minus, because whether it is positive or negative, it is going to fetch us the same result. So it becomes what? Plus or minus. The root of what? 64 is what? 8. So what that means is that my p is equal to either positive 8 or my p is equal to what? Negative 8. So the value of p for the quadratic equation that we have over here, for it to have the nature of the roots to be what? Equal roots, the value of p has to be what? Either positive 8 or negative 8. So thank you so much for watching. I hope this tutorial was helpful, and if you indeed find it helpful, kindly drop a like, because that really helps the YouTube algorithm to recommend our tutorials to other students out there that may need the tutorial. So thank you once again for watching, and I will see you in the next video. Peace.